To start off, my name is Olga Silyutina, and I work as a product analytics lead at SumSub. It's like a some substance company that helps you to provide KYC for different tech companies or financial companies and other. Before that, I worked at vk.com, one of the largest social networks in Eastern European countries. One day in vk.com we made a query, and this query had such performance metrics. Let's look at them. ClickHouse proceed about 2 billion rows from the table and elapsed this query in less than a second. So I think you already may be impressed by that, and let's then talk about how ClickHouse may be that fast, how it can be applied in data analytics, in product analytics, and also how it can be placed in modern data stack. So when you have such fast database, basically you can also face with some problems. A lot of managers will have a lot of questions for you because you now can answer them very fast, and every question will take really quick for you to get some numbers and show them for dashboards or just in one graph. So let's talk why ClickHouse is so fast. Basically, ClickHouse provided us with such beautiful GIFs, and you can see there the comparison of relational database and column-oriented database. You can just put MySQL and Postgre for relational database if you worked with them, and for column-oriented we will talk only about ClickHouse today. So basically, when I select some columns, for example, I would like to select from my white table date, region, and a smartphone that user used. And when we do that in relational database, it will select these columns, but before that it will read also all the columns that have this table has. When you do this in ClickHouse, it will select only those columns that you selected, and will provide you data only from those columns, so that little memory will used, and it will work a lot more faster than in relational databases. So what is ClickHouse basically? ClickHouse is database management system, can we call that, and it is mostly supposed to use in OLAP scenarios of work, and we will also talk about what OLAP is. So OLAP is a data discovery process when you need a really low latency of your data, when you have a lot of queries to your data from analysts, from product managers, when you need to create some forecasting from the data that you have. So it is online analytical processing, just like that. And also ClickHouse is column-oriented database, as we already mentioned, and now it is used by really giant companies like eBay, Uber, Spotify, and a lot of startups. And what is also really cool about ClickHouse is that free and open source. So now we can more closely look at comparison between relational databases and column-oriented structures. When you store your data in relational databases, you just put your data in rows and read them as rows. While in column-based databases, for each column you have like a folder in your memory, and you access via select to this particular folder. And also, there are some differences in structures of relational databases and column-oriented databases. For example, in MySQL, you already know that a lot of small tables connected to each other with primary key or another columns that can connect these tables, while in ClickHouse you have a really wide one table that connects all those tables in one. So let's talk about advantages of ClickHouse. As I said, it is applicable for OLAP data processing scenarios, when you have a lot of queries to do, when you have a lot of questions to answer for analytics. It is free to use, it is open source. I know even some startups and companies that hire people who will full-time do some commits to open source ClickHouse GitHub. Also, ClickHouse have a vectorized engine that makes it even faster. And besides the selecting columns from the white table, it selects only those vectors that you need for your query. Also, ClickHouse has a lot of custom functions, and those functions could be used for analytics, it could be used for different ML processes, and we will talk about that also later. Also, ClickHouse has a lot of approximate calculations inside, where all the magic happens, and also for basic functions that you use on daily basis. And we also will cover that with an example of unique and unique exact functions. Also, ClickHouse, compared with relational databases, will have multiple indexes. So it doesn't have primary key as it is in relational databases, but it has a lot more indexes that can be used in different ways, and we also will talk about that. Also, ClickHouse supports replication and sharding. For example, if you have a lot of machines, as we did in vk.com, for example, you can replicate all your data on those machines and save a lot of time and data while processing it. Disadvantages of ClickHouse includes also some points, and probably someone will define others, but I think that ClickHouse can be significantly slowed down by using joins. For example, if you write queries with a lot of joins from different tables or even from one table, you will get a lot more worse performance of your query. So try to avoid using joins, try to use arrays, try to use aggregates, which will aggregate your data before you make a select. Also, data in ClickHouse couldn't be deleted by row in all engines. You can do that only in collapsing engine, but most of the times you can delete only data that is stored in one partition. And we also will cover what partition is and how it is included in ClickHouse, how it is used. Also, ClickHouse not fully adapted for window functions, so probably if you already worked with MySQL, you worked a lot with window functions. ClickHouse do have now some new window functions in new releases, but they're not so perfect as in relational databases. So in ClickHouse we use mostly array functions for that, and you do the same algorithms that you do in SQL in a different way here. Also, as we know, a lot of ClickHouse tables are white tables, and they have a lot of rows. For example, in VK we had more than 100 rows in one table. So when you do select all, you can just kill your cluster. So try to avoid this select all opportunity. Also, ClickHouse is not fully suitable for OLTP. As I said, ClickHouse is mostly implemented in online analytical processing, but for online transaction processing it is not quite well, because ClickHouse can just not store all the data that you need when you do transactions, and while you're inserting the data, you can miss some data while inserting. So be aware of that and try to use it mostly for OLAP. So now let's talk about engines that ClickHouse provides. So a lot of work we do with merge tree family engines. So basically it has a lot of different applications of merge tree engine, from replacing some in merge tree aggregates, and so all of them have their functions and can be applied for different data pipelines that you have in your company. I will talk mostly today about merge tree because it's one of the widest applicable engine for a lot of tasks that you may have. Also, ClickHouse have a lot of integrational engines. You can integrate your ClickHouse with Kafka, with MySQL, JDBC. For example, you can read from PySpark, you can read ClickHouse data via JDBC, or you can just copy your data from MySQL to ClickHouse, but it's not really good because when you copy your data from MySQL, you still will do MySQL queries undercover. And for special engines, there are a lot of engines that could be used in special occasions, I would say, in special tasks that you have. And I will talk mostly about materialized view because it's something that not really every database has. And I will talk about dictionary and how it also can be applied to maximize your efficiency for your queries. So starting from merge tree, your create table will look like that. Firstly, you write all your columns that you have. For example, here I have an example of advertisement data that I mostly had in vk.com, for example. And you have engine, and here we use merge tree. It's like a basic table that you will use in analytics, and then partition by date. So let's dive into partitions and what they mean. Basically, partitions is like also folders that stores your data in a partition that you provided in create table. For example, if I provide it as a partition column date, it will store my data in some folders like that with the number of day which data was stored. Also, you can get those partitions from a special table in special scheme system in ClickHouse, so you can just look at them, understand how they are organized inside your table. Now we will talk about how to effectively use partitions in ClickHouse. For example, you have a really large table. For example, in VK or in SumSub, you have thousands of events, millions of events every day. And for such large tables with raw data, it's better to use partition by week or by month, so that while ClickHouse will merge your data while storing, it will not spend a lot of memory for that. But when you have a smaller data, you can partition it by day as well, and you will have an opportunity to delete by partition more precisely than it will be with week or month. And of course, you can use in partition by key not only date time values. You can use, for example, a column with some categories of your companies, of your clients, or something like that, if you do not have any data columns. Next one is order by keys, so it's like sorting keys, sorting indexes. As I said, in ClickHouse we do not have primary key as in relational databases, but basically the first one column that you will write in order by, it will be very similar to primary key in relational databases, but it differs from that because this key can be duplicated. So it can have more than one presence in your data schema. Also, when you apply filters in your where query, the index that you specified in order by will sort all your data before applying filtering. And that's how it looks inside. So basically, as ClickHouse doesn't have any primary key or indexes, but it has order by indexes, it has such word as marks. So it marks your data, sorted data, and somehow cluster it in groups, and then ClickHouse will search only in a group that is suitable for your filter. That's how ClickHouse helps you to make your queries even more efficient. So next one is sample by. And basically, sample by is something that is more optional, I would say, but your analysts will be very grateful if you will set up sample by index. So what does sample by does? And sample by index is the index that helps you to get your samples by particular column. For example, in statistics, you would like to get 50% of all advertisement banners that you had in your advertisement platform. And if you do not have any sample by index, it will get you random rows. But random rows, it's not the same as random unique IDs, and we will cover that in the next slide as well. So you see, when you have raw data with add ID event like click or view and time, you can have in this data more than one add ID showing up. And for example, your add ID can have 2 clicks in different time. And when you would like to sample only add IDs, you need to sample them in this way, but not in this way as in the middle. So when you do not have sampling index, it will just take some random rows, but you will miss this row here, and it can be a problem if you do some statistical manipulations with data. But if you would like to have another column for sampling, for example, you have also user ID in your data set, but your sampling is add ID, you can apply city hash function that already presented in ClickHouse, and these 2 queries will show you same results. So you will have each second add ID in your database. Yeah, now we are moving to dictionary engine, and dictionaries is something really similar, as you can imagine. It can have more than 2 key values pairs, and your dictionary can be applied to your select queries with the function dict_get. So, for example, you have a table, a wide table with a lot of events, and you write for each event a city where this event was held, and it can be a problem if you store a lot of strings and like with city names. So to avoid that, you can write IDs for your cities, like 1 for Moscow, 2 for St. Petersburg if you live here. And also you can take dict_get functions to apply your strings with names of the cities to it. Then we will move to materialized view, and it's something that really does magic in ClickHouse, because, for example, probably you already know about views, which are mostly presented in all databases. And what view is when you write a select query, and then every time you try to use this select query results, it will just do this select query every time you press the button run. But materialized view also have cache, and it stores in some cached form your data and helps you to get this data more efficiently. So materialized view helps you to create real-time aggregates, basically, based on your select queries, and it is more faster than basic view engine. And here I would like to present you an example just for understanding. For example, we have in SumSub, we can have such documents with a lot of data on them, and we have OCR model that tries to find some text in this document. And most of our data is stored in large ClickHouse table. It is really similar to data lake, and it is stored in column called metadata in JSON format. So for analytics, it is not really proper, and every time we write a select, we need to write JSON extract functions in ClickHouse, and your queries start to look really huge. So to avoid that, we can create a materialized view that will transform this JSON data in metadata column to 3 columns and make you a standard ClickHouse-wide table for product analytics use. So how we do that? We just write another create table query where you show how your new table with materialized view engine will be named. Also, you write here your query. And this is also native ClickHouse functions with JSON extract. You can extract rows, strings, ints, and a lot more. So we just extract all the needed data from metadata that we have, and after that we will get our beautiful table that is easy to use in product analytics on a day-to-day basis. Yeah, so now we will move to variable types. We talked about this part of the create table query, and now we will talk more about this part. So basically, ClickHouse isn't really good working with such types as string, floats, and nullable variable types. And when you have a lot of data, huge amounts of events in your ClickHouse database, it is not really efficient to store all this data every time you write an event. Basically, you will duplicate all of them with a string, and it's really heavy for your memory. So for alternatives, you have low cardinality string. It's one more magic feature from ClickHouse. So what does low cardinality function makes? So it's just compressed all your strings that you have and create them in a more efficient format for ClickHouse. But for you, it's just a string, so you will see it as a basic string as always. But here is an important tip also. You need to use only those list of strings that that have like not more than, I would say, 20 or 30 unique values. So if you have more values, for example, you write down strings with text from, I don't know, from your comments section, and every other string differs from previous. So here, low cardinality probably will not help you a lot. Also, if you would like to write some floats, probably you need to make a decision into other relational databases or databases that are more suitable for OLTP. If you have a lot of columns with float variables. But if you can round them and write ints, do that, and you will save a lot of memory for your company. Also, nullable is a special function in ClickHouse that writes a null variable in a row if data is absent. So if you do not really need to know that this data was missed, and you can write down 0 instead of that, you can do 0. It also will be more lightweight. So now we are moving to syntax of ClickHouse, and I would like to show you how basically all the functions in ClickHouse are made of in terms of syntax and words. So, so for example, we have a function array. we just can add to that function another word, enumerate, and another function, unique. And now you have one new function that calls array enumerate unique. And basically a lot of functions in ClickHouse are setting up by this set of words, a set of even different functions. So as with conditional functions, we have a basic functions called if in ClickHouse, where you can just write condition and what you expect to be in your column after that condition. But also you can use this if function with the sum function, count, argmin function, and a lot of more aggregating functions. So you make in from conditional function and aggregating function, conditional aggregating functions. So you will have some if. Here you can write a column, for example, money, and then after a comma you will just write condition and calculate the money only for example, iPhone platforms. And also ClickHouse has multi-function. Probably you heard of similar function in SQL and a structure of case when. In ClickHouse we have a multi-function for that, and it is more compact and probably easier to read. Also, as I said at the start of the presentation, we have approximate calculation inside the ClickHouse, and also with functions that can be applied in your queries. So like that, you can have unique exact function and unique function. What does unique exact is calculating the unique amount of your add IDs in your table, and it will be really precise, and it is similar as count distinct, and it will have the same answers. But if you really do not need to know how many advertisements you have, like particularly for every advertisement, and you can make it more approximate, you can use unique function. It will work a lot more faster and will provide you results with some percentage of difference. Also, we have a lot of array functions. In ClickHouse, we can, for example, when you do ranking in MySQL, you will apply a window function, but for ClickHouse, you will use group arrays and array enumerate to provide ranking for your IDs. Also, ClickHouse has array map, and it is similar like for each loop in Python probably. So you can set up a variable, and for each variable in an array you will add 2, and in the result you will have each number in this array with +2. Also, ClickHouse has a lot of analytical functions that already do a lot of work for you. For example, you can have retention function that already calculates all the retention. For example, before I knew about this function, I did retention with joins, but you can avoid that and use this function. And also they have window funnel, and you can calculate how your events goes from first event to the goal event. Also, ClickHouse has a lot of ML functions, and you can use machine learning inside your queries, inside your database, and it's also very interesting, and I think that we need another, another presentation about ML applications in ClickHouse. And also about some special syntaxes. In ClickHouse we can use pre-where. It's like where, but it uses this filter to execute your filters on the first place. So it will also save you time if you will filter in this pre-where query, for example, for partitions or some order by keys. Also in ClickHouse we have limit by. And it helps you to have a top, for example, of some categories in a particular group. And also we have a sample, and sample we already mentioned earlier. And a little bit about data stack that you can use with ClickHouse. Basically, as ClickHouse now used at Uber, at eBay, and all its giants, it already has a lot of connections with different open source and not open source tools. Here I present like the simplest model. All your data that you would like to put into ClickHouse is better to store firstly in Kafka, because when you store it here, you will not miss any data if you would insert it to ClickHouse directly. Then from ClickHouse you can make some aggregates from raw data in Airflow, and then you can visualize all your data via, for example, Superset. It's also Apache open source tool, and yeah, like that. It worked at vk.com, it works at SumSub, and I also read a lot of articles about such data stack, and you can also try to apply that. And yeah, I hope that it will inspire you to use ClickHouse somehow, and you already like this guy here waiting for ClickHouse. So, questions?
Could you please give examples of practical applications of ClickHouse, like right now in businesses, in what sectors it is applied?
So sectors, you mean like finance or something like that? Basically, in all the spheres, as I worked in social network, ClickHouse was used there, and now I work in KYC company. It is also used here at e-commerce. Basically, they started as a company that helped to save clickstream data, and it was very applicable for ad tech, for advertisement data, for all clicks and views you have with your banners. But now it can be used in really many different spheres.
Yeah, as you already told, you have used the materialized used to store some data from ID cards, right? The question is more about the solution. Is that just experimental solution? Because personally, I would prefer to save that kind of data in a traditional way, like using any relational database or NoSQL database.
Mm-hmm.
Is that a solution with a benefit, or is it just experimentation?
Honest answer is experimentation. But now I understand why it started like that, because we have a lot of different answers from ML models, and they're not every time like particularly really need to be stored in a relational database, and there are so many events and so many answers from ML models, so that we just can't use them, in relational basic databases, and we need more large data storage for saving all this data.
Thank you for the presentation. I was wondering whether the ClickHouse can be used with multiple devices to make queries, because currently I'm working with a huge data set, and as I am new in the sphere of data science, I was trying to find a solution to make quick analysis. I was working with pandas. The thing is that I switched to PySpark.
Mm-hmm.
It's faster, but it's not fast enough for me. And I was wondering whether I can apply ClickHouse with multiple devices. Yeah,
basically you can. By devices you mean what do you mean by different devices? It's like computers or machines where you store the data?
Like CPUs and
okay. Yeah. It can be even replicated by those CPUs and sharding between them, and it will also make this more efficient. So you can store your data at all your CPUs you have, and it will be very fast, and probably you will even just be satisfied with what you will have with one machine already, because ClickHouse, in my experience, is way more faster than Hadoop and PySpark connection. So yeah, try it out.
Thank you. I'll try it.
Yeah. Yeah, thank you for the attention.